Okay, Year 12, I'm going to have another go at, or finish off doing the equations of chords. This time we're going to look at the equation of the chord to the hyperbola. The previous clip did the equation of the chord to the ellipse. Essentially, though, we're going to be using all the same sorts of things here. We're going to use our sums and differences of angles using trigonometric formulas. And we're also going to use this little bit here that we did, which is letting theta equal a plus b and phi equal a minus b, and all these different results that we talked about last time. So if you don't know, or you haven't watched the previous video and you're wondering, well, where all these results came from, you need to go back and have a look at that previous video or clip and make sure you understand where they all come from. They're not too hard. All these ones that have been typed and underlined in red and blue are standard from our reference sheet, and then we just use those equations that we've got there and we add and subtract them, and we get these ones down here. Okay, so let's have a look at the hyperbola and see what we're actually talking about. So here's a standard hyperbola. It could be any hyperbola, and if we're thinking that we're going to take a chord, so let's put this point P here, and we'll give it its parametric representation, which is a sec theta and b tan theta. And we can draw a chord to anywhere on any part of the ellipse. So we can draw a chord within the one totally on the right. And there's a chord, sorry, I said on the ellipse, on the hyperbola. We can go across town, and there's another chord. We'll call that N. So we've got the chord PM, we've got the chord PN. We can go just purely on the left-hand side. And there's the chord, we'll call that Q and Q. Well, let's give that Q value its set of parametric representation. So we'll call it A sec, well, we better choose a different angle, and let's choose phi, and B tan phi. And there's a parametric representation of a point on the parabola Q. And let's now find the equation of that chord PQ. Now, it wouldn't matter which one of those, whether we chose PM, PN, NQ, it doesn't matter. As long as we're just going between 2 points on the hyperbola. So how are we going to do this? Now, this is a part that's pretty easy. We're just going to use y minus y1 equals m outside of x minus x1. But the algebra gets pretty heavy here, and you might get lost along the way, but just please keep in your head the concept, all the algebraic gymnastics aside, is just using that. We're going to find the gradient, we're going to sub in a point, and we're going to try and work it down until we get to a nice, easy equation of what the equation of the chord is. So the first thing is to find the gradient. So if we go m, the gradient, well, it's the y values. So we go b tan theta minus b tan phi over the x values, b sec theta minus b sec phi. Okay, we'll take out the b and we'll get tan theta minus tan phi, and sorry, up here, that should have been b, but these should have been a's. First mistake. Let's see, hopefully I won't make another one. So a sec theta, a sec phi. So we'll take out the a and we'll get sec theta minus sec phi. Well, let's take that b and a right out, because we're going to do some heavy algebra with the stuff on the right, and we don't want to get it confused. Well, tan theta, well, that's sine theta on cos theta minus sine phi on cos phi. There's the top line. And sec, well, sec is 1 over cos theta minus 1 over cos psi. All right, so now it's getting a bit complicated. I've got fractions on fractions, but that's okay. Let's see where this leads. So you have B on A. Let's get a common denominator on the bottom, on the top. So we've got this line here, and we're just going to look at this one here. We're just going to look at this one here. So to get a common denominator, I multiply the two denominators, and I've got to multiply through on the top. So I'm going to get sine theta on top times cos theta minus cos theta sine theta all over cos theta cos phi. I'm sorry, that should have been a cos phi. And that should be a sine phi. On the bottom, going to do the same thing. So I'm going to get cos phi minus cos theta all over cos theta cos phi. Now, when we divide by fractions, we multiply by the reciprocal. So let's just write the top one. But let's have another look at the top one. What can we do with that top one? Let's just have a look at what this is here. Sine cos minus cos sine. Well, let's go back to these things that we were talking about. Sine cos cos sine. Sine cos minus cos sine. And we can see it here. Sine something, cos something, minus cos the same thing, sine the same thing, is A minus B. So let's write that. That yellow bit there, let's write that as sine theta minus phi. And it's all over cos theta cos phi. Now we're going to multiply by the reciprocal of what's underneath. Well, cos theta cos phi. And here I've got cos phi minus cos theta. Well, that's pretty cool because these two things are going to cancel out. So we've got B on A times, and now it looks pretty simple, sine theta minus phi over cos phi minus cos theta. Well, we need to go back here because that theta minus phi looks like something I need to use. So if I go back here, and if I see theta minus phi, you'll see that there it is. Theta minus phi is 2b. All right, excellent. So let's go back here. And let's write these things so we can keep them. 2b equals theta minus, let's fix that up, phi. And later on we're going to go, well, b equals theta minus phi on 2. All right, so that means here on top, I've got my B on A hanging out the front, leaving that alone, and I've got sine theta minus phi, which is the same as sine 2b. All right, now I want to have a really close look at this next one because you might find this a bit hard. This one here. cos theta minus cos phi minus cos theta. Okay, so let's go back. Oh, there it is. Oh, hold on a minute. It's the wrong way round. It's the wrong way round. What I need is the other thing. I need the cos theta first. Well, let's see if we can fix that up. So I can write if I multiply through by a negative, then it equals negative cos theta minus cos phi. So I can put that in at the bottom. Okay, so let's do that. So I got negative cos theta minus cos phi. Right, see that neat little trick there? From that, I just multiplied through by a negative, which changed the sign. Okay, back to the numerator. B on A. Well, sine 2b is 2 sine, is sine b cos b plus cos b sine b. That's our double angle formula. And underneath here, I can now change that. I can now change this to what was written above. So let's go back and have a look at what it was. And here it is. Negative 2 sine theta plus 2 sine theta minus, negative 2 sine theta plus phi on 2 and sine multiplied by sine theta minus phi on 2. So we've got a negative, and then we've got negative 2 sine theta plus phi on 2 times sine theta minus phi on 2. Okay, B on A. As I said, it's getting complicated, and it's still a bit to go yet. Well, up here, we also said that B was equal to that. So let's put that back in where these B's are. So I get sine theta minus phi on 2 cos, oh no, we'll make it a bit easier so we can do the substitution later. That's two of those things, isn't it? Sine B cos B, that's two sine B cos B, and then we'll do the substitution of B back in a minute. Negative gives me a 2, and then I've got sine theta plus phi on 2 sine theta minus phi on 2. Now you can see straight away the 2's are going to go. Let's progress a little further. We've still got that B on A sitting out the front. Now we'll put the B's in. Okay, so we're going to put the B's in here and here. So we get sine theta minus phi on 2 and cos theta minus phi on 2. And that's all over sine theta plus phi on 2 sine theta minus phi on 2. And look at that. We now get to cancel that and that. So now we get it. Well, we're almost there. We're almost there in terms of, and we're still, well, we're almost there in terms of getting the gradient. We get B on A cos theta minus phi on 2 all over sine theta plus phi on 2. Whew! So that's our gradient. That's our M. Now remember our point P, we'll use P, we could use Q, is A sec theta, B tan theta. Okay, so we use a point gradient formula now. So y minus y1, well, that's B tan theta, equals B on A, all this cos theta minus phi on 2 sine theta plus phi on 2 times x minus a sec theta. So what do you think? That's my y minus y1 equals my m outside of my x minus x1. There's my formula. And that's a concept you've got to hold on to. Hold on to that. And let's see if we can now move this away. So here I'm going to do some funky stuff. I'm going to divide the b. I'm going to divide the b through over here. I'm going to divide that b. So I'm going to do this step by step. Y on b. And those b's will cancel there, so I'll just get minus tan theta. Let's take the a through the outside. So I'm going to just leave this cos theta on 2 here. So cos phi minus theta minus phi on 2 on sine theta plus phi on 2. I'm going to put the a into this x bit. So I'm going to have x on a, and the a will cancel with this one, so I'll just get sec theta. Okay, now we're feeling much better now. Now, I'm going to take the sine theta. I'm going to take this sine theta and I'm going to multiply it across over here. I'm going to multiply that cos theta through there. So let's see. I'm going to get y on b sine theta plus phi on 2, all right, minus tan theta sine theta plus phi on 2. There's my left-hand side. On the right-hand side, this cos theta goes through, so I get x on a cos theta minus phi on 2 minus sec theta times cos theta minus phi on 2. All right, so it's getting a bit harder now. So I'm going to bring the y across, and I'm going to take the sec over. But I'm going to write all the x and y on the left-hand side. So even though I'm writing this on the left-hand side, realise what I've done is I'm going to take that y over there, I'm going to take that sec over there, but I want to write my x and y on the left-hand side. So what I've got is x on a cos theta. I might thicken this pen up a bit. Theta minus phi on 2. All right, and I'm moving that y on b to the other side, so it's going to become minus y on b. Don't forget your sign. Sine theta plus phi on 2 equals. So even though I'm writing this on the right-hand side, I've moved the sec over, so it's positive sec. Sec theta cos theta minus phi on 2 and I've got minus tan, come on, move across, minus tan theta sine theta plus phi on 2. Right, now, the left-hand side, I can pretty much let go for a while. All right, I've got my x cos, okay, I've got all that. That's how it's going to stay. That left-hand side is done. The left-hand side is cool. I'm going to leave that like that. X on A, cos theta minus phi on 2, minus y on B, sine theta plus phi on 2. And that's what we got for the chord on the ellipse. But I'm just going to try and tidy up this right-hand side. So the first thing, tan theta is the same as sec theta sine theta. And why do I want to know that? Because I'm going to factorise out the sec theta. I'm going to factorise out the sec theta. And if you don't believe me, remember sec theta is 1 on cos theta times sine theta. So there you go, you can see it. So here we go. Let's focus in on this. So I'm going to take sec theta out. And what am I left with here? Cos theta minus phi on 2 minus, what did I say if I take sec theta out of that? I'm going to be left with sine theta. So sine theta sine theta plus phi on 2. Wow, I'm almost there. Look at this. I'm getting better and closer all the time. But if you look at these two, that's got a minus in it, that's got a plus in it. Now this is a really neat trick. I'm going to change this one here so that I've just got a plus. I want to get rid of the minus. I want to be able to get rid of them. So here we go. Sec theta, that's out the front now. What have I got here? Watch what I do here. I'm just going to rewrite this fraction here. I'm going to rewrite it as 2 theta minus, and watch this, I'm going to put brackets here, theta plus phi, and that's all over 2. Can you see that I have not changed it? Because 2 theta minus theta is theta, and when I put the minus in those brackets, like minus, it'll come out as theta minus phi on 2. All right, just make sure you understand that while I write out the rest of it. I'm not changing the rest of it. Sine theta plus phi on 2. Now, as long as you're happy with that, I'm going to rewrite that. Sec theta. Now, cos, I'm going to write it as 2 separate fractions. Theta, because 2 theta on 2, minus theta, oh, and that was a phi. It's a phi, it's not a theta. Phi on 2. Oh, now it's looking good. Now, sine theta plus phi on 2. Okay, because now this is, I can use my formula. Cos, sine, sine. Okay. So sec theta equals, right, now watch this. I'm going to write all this. I'm going to write all of this here. So watch it now. So it's cos theta plus phi on 2. So cos plus sine theta plus phi on 2. Now that's all that green bit. Those two bits are the same. Cos. Then I've got minus sine theta plus phi on 2. Right, and watch this. Here we go. Now we're almost there. That and that cancel each other out. That and that cancel each other out. So I get sec theta. Hold on, sec theta, let's write that. Let's write that as 1 on cos theta. And what's left here? Cos theta and cos theta plus phi on 2. The cos thetas cancel. So finally on the left-hand side, we get there cos theta plus phi on 2. And what's on the left-hand side? Remember what's left on the left-hand side? There, it's all there. It's x on a cos theta minus phi on 2 plus y on b sine theta plus phi on 2. And that is the equation of the chord between any 2 points on the hyperbola. Now, it's a lot of work. I couldn't believe it, how much work it was. Hold on, I think that's minus. Yes, sorry, I made a mistake. Danger. Make sure, there we go, minus. There we go, so it's minus. So x on a cos theta minus phi on 2 minus y on b sine theta plus phi on 2 equals cos theta plus phi on 2. Now, I don't think that they will ever ask you to prove that. I mean, it's just phenomenally hard. Look at all the stuff you have to do. All right, you have to know all these trig formulas. You are using a very simple principle, y minus y1, but the algebraic gymnastics to move all the way through that to finally get to that is pretty hard. But you've seen the proof now, and you should be able to do 6C, questions 1, 2, 3, 4, 6, 8, 11, 13, 15, 16. Good luck.